Hello everyone and welcome. Are linear equations and word problems causing you some stress? Don't worry, you are not alone in that feeling. Many students find these topics challenging, but I promise by the end of this session, you will be approaching them with much more confidence, maybe even like a pro. Today, we're diving deep. We'll cover exactly how to set up linear equations, the step-by-step process for solving them, and crucially, how to apply these skills to those tricky real-world problems. Whether you are gearing up for your SAT, GMAT, GCSE, IGSE, or any other high school or college entrance exam, this guide is specifically designed to help you succeed. So, grab a notebook, get ready to focus, and let's dive in. First things first, what exactly is a linear equation? At its core, a linear equation is any equation that, if you were to plot it on a graph, would form a perfectly straight line. That's where the linear part comes from. It usually appears in a standard format like ax plus b equals c. Here, a, b, and c represent constant numbers. They don't change. X is our variable, the unknown value we are trying to uncover. Our main objective when we see an equation like this is to find the specific value of x that makes the entire statement true. It sounds simple, and with the right approach, it really is. All right, let's get our hands dirty with a basic example. 3x plus 5 equals 20. Our goal is to get x all by itself on one side of the equation. So, let me rewrite the equation down. 3x plus 5 equals 20. Now, we already have x on one side of the equation, so we need to deal with this plus 5. And in order to remove this plus 5 from the left-hand side of the equation, we have to carry out the opposite operation on plus 5. And the opposite operation of addition is subtraction. And so, we subtract 5 from both sides of the equation. So we'll have 3x plus 5 minus 5 is equal to 20 minus 5. 3x plus 5 minus 5 is 0, so we have 3x is equal to 20 minus 5, which is 15. Now, to further isolate x, we need to carry out the opposite operation of multiplication, as we can see that 3 is multiplied with x, and the opposite operation of multiplication is division. And so, we divide both sides of the equation by 3. Okay? So, this 3 in the numerator will cancel this in the denominator. And 3 goes here 1 time and goes here 5 times. And so, we have that x is equal to 5. Simple, right? Now, let's tackle what many find to be the trickiest part: word problems. But here is a secret. Word problems are essentially real-life stories or puzzles that have a linear equation hidden inside them. They describe everyday scenarios, and our main task is to carefully read the story, identify the key information, and translate that language into a mathematical equation we can then solve. Once you can do that, you are halfway there. Let's walk through an example. Here's the scenario. Sarah buys 3 notebooks and 2 pens, and her total bill is $19. We are also told that each notebook costs $5. The question is, what's the total cost of each pen? First, let's define our unknown. We are looking for the cost of a pen, so let's call it P. So let cost of each pen be P. Okay? Now, let's build the equation. The total cost is made up of the cost of notebooks plus the cost of pens. Now, what is the cost of notebooks? She buys 3 and they are $5 each. So that is 3 times 5. So 3 times 5. Cost of pens. She buys 3, or she buys 2, and we are calling the cost of 1 pen P. So that is 2 times P, or 2P. The total cost is $19. Total cost $19. So our equation is three times 5 plus 2P is equal to 19, or 3 times 5 is 15. So we have 15 plus 2P is equal to 19. We subtract 15 from both sides, and this gives us 2P equals 19 minus 15, which is equal to 4. We divide both sides by 2. We have 2P over 2 is equal to 4 over 2. So P is equal to 2. And so each pen costs $2. A huge part of mastering word problems is learning to translate common English phrases into their mathematical equivalents. It's like learning a new vocabulary. Let's look at some common ones. Phrases like sum, total, increased by, or more than almost always mean addition. So, a number increased by 7 becomes x plus 7. Words like difference, less than, or decreased by point to subtraction. The difference between x and 3 could be x minus 3. Be careful with less than. 5 less than x is x minus 5, not 5 minus x. Product of times, twice, or triple indicate multiplication. Twice a number is simply 2x. Quotient of, divided by, or per, like meters per hour, suggests division. And crucial words like is, are, equals, or results in translate to the equal sign. Recognizing these patterns will make you so much more confident when you are starting down or when you are staring down a complex word problem. Practice spotting these keywords. Let's tackle another popular type of word problem, age problems. These often involve comparing ages or sums of ages. Here is one. John is 3 years older than Anna. Together their ages add up to 27. How old are they? First, let's define our variables. It's often easiest to let the simpler age be x. Let's say Anna's age is x. So, Anna's age is x, all right? Since John is 3 years older than Anna, John's age can be represented as x plus 3. So John's age x plus 3. The problem states that the sum of their ages is 27. So Anna's age x plus John's age x plus 3 equals 27. Our equation is x plus x plus 3 equals 27. So we have that 2x plus 3 is equal to 27. We subtract 3 from both sides of the equation. We have that 2x equals 27 minus 3 equals 24. We divide both sides by 2. This gives us x is equal to 12. So Anna or Anna's age is 12. John's age 12 plus 3, since John is 3 years older, is equal to 15 years. To consistently conquer word problems, it helps to have a reliable strategy. Here is a 5-step toolkit. 1. Read the problem carefully. And I mean really carefully. Read it at least twice before you even think about picking up your pen. Make sure you understand the scenario and exactly what question you need to answer. 2. Define your variables clearly. Decide what unknown quantity your variable will represent and explicitly write it down. For example, let x equals the number of apples. 3. Translate the words to math line by line or phrase by phrase. Don't try to swallow the whole problem at once. Break it into smaller, manageable chunks and convert each piece into mathematical terms. 4. Solve the equation systematically. Use the algebraic steps we have practiced. Don't rush. Ensure your work. This helps avoid careless errors. 5. And this is crucial. Always check your answer. Plug your solution back into the original word problem, not just your equation, to see if it makes logical sense. For instance, if you calculate a negative h, something is going wrong. All right, theory time is over. Now it's your turn to practice. I've got a couple of quick problems here for you to try. Problem 1. A taxi charges a $3 base fare plus $2 per kilometer. If a ride costs $15, how many kilometers were traveled? Problem 2. Twice a number minus 4 equals 10. What's the number? I want you to pause the video right now. Grab your pen and paper and work through this. Once you think you have the answers, you can find the solutions in the pinned comment or the video description below. And we are back. How did you do on the quiz? I hope you are feeling more confident. You have just taken a big step in unlocking the power of linear equations and word problems. Remember the key takeaways. Linear equations form straight lines. Solving them is about isolating the variable. And word problems are all about careful translation before you solve. If you found this lesson helpful, please give it a big thumbs up. It really helps the channel. And don't forget to subscribe to Laureate Academy and hit that notification bell so you don't miss out on future lessons. I would love to hear from you. Let me know in the comments which math topic you would like me to cover next. Your suggestions help me create content that you need. Thanks so much for watching. Until next time, keep practicing and stay math strong.